Now we're going to get into the more precision part of doing piston to valve on your motor. When you've got something that you don't know, you need to mock everything up. This is the head we're going to run on this particular project. Tools I'm going to need. I need my calculator. I need a mock-up piston, which this is going to be the real piston. Of course, my little bracket, dial indicator. I'm going to need calipers this time because I'm going to have to measure radial clearance. And one of the first things we'll do in this part of the operation, which you probably can't see there, is we're going to center punch this piston. And the first thing we want to check is our radial clearance, because if we don't have enough radial clearance, the valve will tell you you don't have enough piston and valve clearance, and you might fly cut when all you needed was radial clearance. You didn't need to physically cut this flat spot of the piston. We're going to need a head gasket that will be the real thickness. This one happens to be crushed to 39 thousandths, which is what we normally run. Here's a center punch tool. I used an old titanium valve. It's 11/32, so I can center punch it. I got several tools I use here for mapping out the angle of the pocket. Sometimes you don't need to fly cut way down in here on the piston. You just need to correct the pocket angle, and a lot of times that's all it needs was the pocket angle corrected. One of the worst things you used to see on a big block is right in here, they fly cut this whole pocket and it gets into the top ring groove. So we use these to check. We got a little weld on them. Don't know if you can see that through the camera. And we got a mark up here that lines up to that weld, and we'll just what we call sweep the pockets. So we'll use these dial calipers so that we can check our radial clearance. This will be the first thing we'll do is center punch. Then we'll check our radial clearance. Then I'll sweep the pocket. I'll have all that math done, and then you can do your mock-up piston to valve clearance for this particular part of this operation. We will create a map of sweeping the pocket so that if we have to take it to a machine shop, in our case out to our own shop, I can give it to the mill operator and he can follow. The thing to not do to these pistons before you start this project is do not deburr them unless you need it to clear your combustion chamber. These sharp edges right here come in real handy for the mill operator when he's trying to find points that you're going to put on your little map when you start sweeping the pockets. One other thing we do when we're getting ready to mock up a motor, you want to take this piston and make sure it doesn't rock in the bore. So what we do, I got a tape from the store, hardware store, that doesn't overlap my oil ring, and I will put enough tape around this that it will make this piston tight in the hole. That keeps everything square, so when I'm center punching or sweeping the pockets, I'm not getting a false reading. The next thing we're going to want to do, since we're doing all our checking at 10 degrees, it's not really going to matter 10 degrees before or 10 after, but I'm going to put it at 10 before. And what we're going to do now is center punch the piston so that we can measure for radial clearance to make sure we got no interference when we're doing this testing. In my case, I made my own center punch tool out of an old valve. You can buy a center punch tool or you can make your own, whatever. So what we're going to have to do, I've got the piston in place, and then I'm going to set the head on here and we'll show you the next step. That's the same thickness as the head gasket I'm going to run. Simply, in this case, insert my center punch valve. You just tap it. We're not driving nails. Okay. We now want to punch in our valve size, which in this case is 2.300 divided by 2 to equal 1.150. And since we're looking for radial clearance, we're going to add 0.050. That'll give us 1.200. So then we'll go to our dial calipers and we'll dial them in. 1.200. We'll then take our piston, take where we've center punched, and put this in the center punch hole, and we'll do a sweep to make sure we got radial clearance. As you can see, we do. So in this case, we can carry on. Then we'll go to the same formula for exhaust. Our exhaust valve is 1.880, 1880. Divide that by 2, which will equal 0.9400. Then we will add 0.050, and we come up with 0.99. Okay. This one should swim. As you can see, the exhaust, they gave plenty liberal clearance for that. What we're going to do now, we are going to sweep the pockets to check pocket angle. A lot of times you'll find a piston, when you're having trouble piston valve, a lot of times it's the angle. It's not necessarily the total depth. And there's no reason to take 100 thousandths out of this end if it's only hitting up here. And if all you did was straighten out the angle, you may have stopped long before this ring groove, because a lot of pistons, this gets too thin and this is what lifts. So we want to come up with an angle, and how I'm going to do this is I've fixed a little tool. It's got a little scribe on it. Same here for the intake side. I'll put this in the head, we'll mock everything up, and I'll show you the rest of the way to get to sweeping the pocket. Over here where my scribe on the valve is, so we will start to spin this around. And in this particular case, this is an angled milled piston and this is an unangled milled head, but it doesn't matter for our checking purposes. So you set 0 at the lowest point. You see I fell off there, so we know. Let's make sure. Okay, so we'll call that 0. So that would be, we would come over to our map and we would draw, that's where our 0 is. Okay, let's see if I can swing. Okay, we will then swing the notched edge, our indicator part of this, and there's 15. So then I'll come over here, draw a line. This is plus 15 thousandths. We'll swing it around to the other side. And where this drops off, let's just call it 10 to round it off. And what these are, this is that line on the piston. And this is plus 10. Since this valve size is 2/300, we would set our cutter to cut 2/400. And then we would correct this angle. In this case, I said in this case, that's an angle milled piston and that's an unangle milled head, and that's why we're having to cut more down in here than we normally would. Generally, it's the other way around on most projects. Another thing, you just don't want to take this piston and cut 100 thousandths. If you cut these two pockets, that's the biggest part of your piston. If you want to cut compression, take it off the dome, not out of the valve pockets. You want to keep these pockets within reason on piston to valve. And my goalpost usually is 75 on the intake and 120 on exhaust with stainless valve motors. The same steps on exhaust. We got to try to find our 0. In this case, it's right here at this point on Okay. It's right here at this point on the exhaust. And then we'll follow it around. We'll go to right here at this point. That's 6. 6 thousandths. Over here is, we're on back, will still be 0. So it's really only 6 thousandths off on the exhaust pocket. So now you will save this map. You will also write it on the piston for whenever you take it to your machine shop should you need to cut it. To make sure there's a scribe line in the piston, you'll push down on these tools so that the scribe end of this valve will leave a line on the piston. Same thing on the intake side. As you can see, these scribe lines here with these points should coincide with what I've drawn over here on this map, and should help when you take this to the machine shop for him to set this piston up to correct this angle. I'll now get the head ready and we'll mock up piston to valve to see if we even need to cut it. We're now back to where we started in this operation. We're going to check piston to valve with the head on it. I have the head gasket, same thickness we're going to run. I have the head tightened down. I get the rocker arms are set at the lash I'm going to run when this is hot. And now I've got it on the split, and I need to bring it around to 10 degrees before TDC to check exhaust. Dial indicator set up on this. Got it set to 0, and now we'll just start cranking it down. 0. There's 120. That was my goal, to at least have that. It's starting to touch, so I stopped. So I got 145 on the exhaust side. I'm using the real springs. They don't have to be the final springs you're going to run, but they need to be similar in tension, because if you use checker springs, time and time again I've seen that come up 20 to 30 thousandths different than what real springs. Real springs load the cam, load the push rod, load the rocker arm, and that gives you your real tension. Now back it back off, and we'll go around and do the intake side. Now to do the intake side, we go to 10 degrees after TDC. Okay. Same thing we just did on exhaust. We'll start cranking it down. There's 50, 60, 70, 80, 90, 100 on this side. So even though the angle is not perfect on this, since I have radial clearance on both valves, and I have more than the clearance that I'm asking for, there's no reason for me to send this and get the pistons cut. I have 25 more than I actually wanted. There's no reason for me to send this piston off. It has plenty of radial clearance. That little bit of the angle off, with me having 25 thousandths extra clearance, there's no reason for me to send this piston and get it cut off. I could go ahead and finish assembling this motor, and we can go on. But if this didn't have enough clearance, that would be the time to correct the pocket and get that issue dealt with. But that would be all I would need to do. Is say I only had 60 thousandths clearance, the pocket's off 15, just straightening the pocket would have got me the 15 I needed to reach my goal of 75 thousandths.